Okay, so now what we're going to talk about are valence and core electrons. So here are shell models for the elements hydrogen, lithium, sodium, and potassium. And now right now these are all neutral atoms because they have the same number of protons and electrons. So hydrogen has 1 proton and 1 electron. Lithium has 3 protons and 3 electrons, and so on. So this is the shell. Whoops. We went back instead of. Okay. So these are the shells or energy levels that the electrons are present in. So you can see that this is, oops, if I keep this going, in each case, shell 1, these are all shell 1. It's the one closest to the nucleus. And in this case, we have 4 shells, so shell 2, shell 3, and shell 4. So potassium has 4 shells or energy levels. So each circle is called a shell, or better is energy level. And we'll get into the why this is better in future lessons. But as you move further away from the nucleus, well, what we see is as the atom gets bigger, each of these energy levels makes the atom itself get actually bigger, the electrons get further away from the nucleus. That's because the distance between the nucleus and outside shell, and distance between nucleus and outside shell increases. So that means the electron's further away, which means it has greater potential energy. The closer an electron is to the nucleus, the more stable it is, and thus the lower potential energy. Lower potential energy means it's more stable. Higher potential energy means it's less stable. So in reality, shells are three-dimensional, and they don't even really look like this. This isn't a perfect representation of what the electron shells look like, but it's more of a 3D model. Remember, we talked about models being something that help us understand complex ideas or complex real-life objects. So these shells are actually three-dimensional, and they have shapes that aren't quite perfectly spherical. So what you need to know about these shells or energy levels, the valence shell is the outermost shell. That still has electrons. So remember, we're going to call them not just shells, we're going to call them energy levels. So the valence shell is the outermost energy level that holds electrons. And because electrons are what are responsible for all bonding, this valence shell is extremely important because these are the ones that do the bonding. It's not the electrons in the middle that are closer to the nucleus that do the bonding. It's the electrons on the very outside. So we really need to understand the valence shell and especially the valence electrons, and these are the electrons that are in the valence shell. And this is really going to help us understand the chemical properties of an element. So the core electrons are the electrons in the lower energy levels, which is to say all those not in the valence shell. Okay, so this is the important vocabulary. Well, let's put them together. Let's put it together with concepts. So the total number of electrons in an element is equal to, let's pick a new color. What do I feel? I feel like orange. So total number of electrons is equal to the atomic number, and this is for a neutral atom. The number of shells with electrons in them is equal to the period number on the periodic table, which is the same as saying the row number. So for example, we look at something like calcium. And take out your periodic tables. I'll give you guys about 10 seconds to take out your periodic tables. I mean, they should be in your notebook, so it should be easy to find. If we look at calcium, calcium is number 20 on the periodic table. It is in the 4th row. So calcium has 4 energy levels. So everything in row 2, calcium, potassium, calcium, scandium, all the way through to krypton, has 4 energy levels. Now the valence level, it is the group number, or the number of valence electrons is the group number on the periodic table. Now, what I want you to do is for groups 13 through 18. Groups 13 through 18, cross out the 1 that in the front. So really, you think of those groups as groups 3 to 8. This is extremely important. I'm going to put this in big, very important. The valence electrons tell you how an atom will respond when it bonds. So you should be able to, we'll come back to an example of that in a second, but you should be able to look at your periodic table, and for groups 1 and 2, and then it says 13, 14, 15, 16, 17, 18, but we're going to call that 3, 4, 5, 6, 7, and 8, all the ones on the right. You should be able to figure out the number of valence electrons for all of those elements, and that will really help you in this class if you can do that. So the number of core electrons stays the same in a row. So all the electrons, so row 2, all has 2 core electrons. Row 3 all has 10 core electrons. But that's not so important. What's very important is the number of valence electrons. So let's look, we'll do 3 examples. Let's go back to calcium again. Calcium is in the 2nd column, which is group 2. So calcium has 2 valence electrons. Now let's look at carbon. Now it might say group 14, but remember I asked you to cross the 1 out in front. So that's group 4. So carbon has 4 valence electrons, which is the same as silicon, germanium, and we're not going to talk about lead or tin. And then last we'll do argon. Oh, I'm going to tell a terrible joke. So I tried to come up with a new chemistry joke, but all the good ones, argon. Oh, get it? Argon. Oh, I'm sorry, guys. I'm really sorry. So argon is in group 8, all the way at the end of the periodic table. These are the noble gases, and they have 8 valence electrons. The only exception here is helium, and helium has 2 valence electrons, but it's in that column for a specific reason. So here it is. I just want you, instead of this stuff here, it should say, I want you to just do 3, 4, 5, 6, 7, 8. So if you haven't done it already, cross those numbers out and make sure that you write down 3, 4, 5, 6, 7, 8 on top of those columns. Like the column with boron in it is 3, column with carbon in it is 4, etc. So you can pause it if you need to take the time to do that. Okay, this was a very important lesson because it taught you a lot of stuff about atomic structure, specifically in terms of electrons. And the question is, why do elements in the same group in the periodic table have similar properties? Well, essentially, because they have the same number of valence electrons. That's the answer. But other stuff to summarize, electrons occupy distinct areas around the nucleus called electron shells or energy levels, and that arrangement is very predictable. For the main group elements, this is 1 in columns 1 and 2, and then the 6 on the right. Elements in the same group have the same number of valence electrons. The number of valence electrons increases across a period, and the number of shells and the number of core electrons increase as you go down a group in the periodic table.